And I did add this sentence or this word. I think the word diverges. I think I added that to your notes. So this is the last formula that we're going to talk about, and that's an infinite, the sum of an infinite. So if I want to add up an infinite number of terms, so your last formula, let me zoom in. The sum of an infinite series is simply T1 divided by 1 minus R. That's your last formula. That's your fifth formula. Now there is a catch. You can only use this formula when the absolute value of your common ratio is less than 1. Okay? So if I'm multiplying my terms by a number greater than 1, that number is going to keep getting larger and larger and larger and larger. But when you multiply by a number less than 1, that number is going to get smaller and smaller and smaller and smaller and eventually approach 0, which is why we call that converges. When the absolute value of R is less than 1, it converges. But if you have an absolute value that is greater than 1, there is no sum because it diverges. So when you look at these two rules, first of all, how do I know this is an infinite sum and not just a regular geometric? What do you notice at the top of the sigma? Let me zoom in. Does everyone notice how we have that infinity symbol? That's how you know we're looking at an infinite sum. All right, it doesn't have a number like the bell work. It's just an infinity, so it's an infinite number. Infinite number of terms. So, do we have a sum for this first one? What is the R value? What's the common ratio? 3 over 2. So this is my question. Is 3 over 2 greater than 1 or is 3 over 2 less than 1? Which one is it? Greater than 1. So because it's greater than 1, this has no sum. This diverges. You would not use the formula. If you use this formula on the test for an infinite series that had an R value that's greater than 1, that is incorrect. You can only use that sum formula if the common ratio is less than 1, the absolute value. So when we look at B, do we have a sum? What's my common ratio? 1 over 5. Is 1 over 5 less than 1 or greater than 1? All right, so 1 over 5 is actually less than 1. So this one does have a sum. Oh, what did you say? Oh, yeah. Yeah, A sub 1, T sub 1, G sub 1, W sub 1. They all mean first term. So this has a sum, and it would converge. I don't know if that's on the test. It might ask you if it converges or diverges. So you should know that diverges is when it is greater than 1, and converges is when it's less than 1. All right, so now let's practice with our formula. Number 1, do we have a sum? So thumbs up if it's a yes, thumbs down if it's a no. 7 over 3 is an improper fraction, which can be written as 2 1/3. So 7/3 is greater than 1. So it has no sum.
And then the way you know it's infinite is just if it has the little.
Yeah, so this here at the top, if this did not have the infinite, then I would use the formula we use in the bell work. So that infinity means infinite. Good questions.
You said we're not getting the formulas for the test?
So we have a meeting today. My suspicion is no, but I will confirm that tomorrow. All right, so do we have a sum for number 2?
Yeah.
We do, because my R value, 0.4, is less than 1. So we can find the sum. So the sum of an infinite series is equal to T1, which in this example would be 2/3, divided by 1 minus R. Go ahead and type that in your calculator. You want to use this one? So if I remember correctly, did you get 1.1?
Yeah.
Or is it or 10 over 9? Either one of those answers would work. But again, you only use this formula, that fifth formula, if R, the absolute value of R, is less than 1. So for example, I'm ignoring that negative because I'm looking at the absolute value. The absolute value of negative 2/7 is 2/7, and 2/7 is less than 1, so this has a sum. Go ahead and try to do number 3 on your own. Number 2, is it negative or positive for number 2?
Positive.
Positive. I gave my calculator away, so I don't know. I'm trusting the class. It's kind of scary. There's this water bottle that's been here for a couple of days. Does this belong to anybody in here? Purple? Okay. So again, it's the absolute value of negative 2/7 that is less than 1. So that's a yes. So we have a sum. So it would be 8 over 1 minus negative 2/7. So my calculator gave a fraction, 56/9. Anyone else get 56/9? Which can also be written as 6.2 repeat. Yes. Okay, so I don't know, you may have stepped out, but this is that formula. It's the last formula for infinite sum. And for infinite sum, it's always the first term divided by 1 minus R. All right, so now let's go ahead and finish up our sequences, and then we'll start our binomial expansion. So we have to find the first 2 terms of an infinite geometric sequence with the given characteristics. So remember, the formula says the sum is equal to T1 divided by 1 minus R. So the sum is 10. 10 equals T1 divided by 1 minus 0.2. Go ahead and solve that for T1. So for T1, who got 8? So T1 equals 10 divided by 0.8 because 1 minus 0.2 is 0.8. And then I multiply both sides by 0.8. And 10 times 0.8 is 8. But it asks us to find the first 2 terms, so you would use your common ratio, multiply T1 by your common ratio to get the second term. So in your calculator to find T2, because this just said find the first 2 terms, T1 is 8, T2 would be 8 times 0.2, which is 1.6. So the series only converges when the terms are getting smaller and smaller and smaller. And that would be your answer. All right, try to do B by yourself, and then we'll start the Pascal's triangle. Thumbs up when you have your first 2 terms. Who found the first 2 terms? I want to give you all a chance to find it on your own before I show you the answers. All right, whose answers matches what I got? I got T1 is 8.4 and T2 is 2.52. Yes. Okay, so once you find T1, you multiply by your common ratio, which is 0.3. So if you take your T1 times 0.3, you get T2. And then if I were to take this number times 0.3, I would get T3. And if I take that number, it just continues. Good question. All right, so last thing I'm going to teach you is Pascal's, and we're done with first semester of pre-cal. So did everyone pick up homework 27 in the front of the room? All right, can you write on there, this is number 1, our last homework. It is a worksheet. It's due on Monday, the 11th. So we're going to learn how to expand a binomial. So for example, if I have 2x minus 5 to the power of 6, how can I multiply that out without taking 2x minus 5 times 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 2x minus 5? Okay, we're going to use a pattern called the Pascal's triangle. So first of all, what is the Pascal's triangle? It's actually it's a pattern. So your row 0 is just the number 1. For row 1, first of all, each row starts with 1 and ends with 1. So row 1 starts with the 1, ends with the 1. It just has 2 numbers. For row 2, then that would be, we start with a 1, we end with a 1, and the middle number is going to be the sum of these two numbers. So if I take 1 plus 1, I have a 2 in the middle. So row 2 is a 1, 2, 1. Row 3, remember you start with a 1, end with a 1. All right, I'm going to add 1 plus 2. That gives me a 3. And then 2 plus 1 is a 3. So row 3 is 1, 3, 3, 1. You will have to build this pattern on the test. Row 4, start with the 1, end with a 1. And we have 3 numbers in the middle. What numbers do you think are going to be in the middle? Good. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. All right, let's just do a couple more rows and we'll end there. I believe your first question on homework 27 is creating the first 7 rows of the Pascal's triangle. All right, so let's look at row 5. Start with a 1, end with a 1. See if you can figure out. There's 4 numbers in the middle. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Who had that for their row 5? All right, last row. And now this obviously never ends, right? This pattern never ends, but I'm gonna do one more row with you because I'm trying to think what's the highest exponent in our notes. Let me see. 4, 5, 5. Yeah, I don't think we go any higher than 5. So we'll end with row 6. All right, so we start with the 1, end with the 1. Go ahead and figure out the numbers in between. One plus 5 is 6. Well, let me pause it. I want you all to find it on your own. And if you notice, it should be a pattern like this. This is symmetrical. Okay, raise your hand if you have the same numbers I have in my row 6. All right, any questions about how to build the Pascal's triangle? So we're actually going to use this triangle to multiply binomials, okay? So let's look at our first example. Number 1, because it says the power of 4, that means I'm looking at the 4th row, row 4. So this is row 4 right here. This is the row I'm looking at. These numbers, I want you to write those numbers, 1, 4, 6, 4, 1. I'm just going to write that because those are the numbers that I'm going to use. If I'm going to the power of 4, that means that my coefficients will be 1, 4, 6, 4, 1. All right, so there are 2 terms. Your first term is A. Your second term is B. So we're going to write this out really slowly. Start off with the 1. And then you're going to start with A to the power of 4. B is going to start at 0. So as one term goes down, the other term is going to increase. So then plus. Then my next number is a 4. Now the A is going to go down and my B exponent is going to go up. So A is going to be now to the power 3. B is going to go up to the power of 1. Plus, the next number in my row 4 is a 6. What do you think A is going to be to the power of what? And what about B? 2. Plus, now I have a 4. A is now to the power of 1. B is to the power of 3. Plus, and then you end off with A being to the power of 0, and B is to the power of 4. So I did one that was really, really simple to start off with, because both of these terms have a coefficient of 1. See how that's a 1A and a 1B, and it's positive. This is as basic as it gets. So the only thing we need to do is clean it up. Anything to the power of 0 is equal to what? 1. So this term would cancel out, and so would this term. So my final answer is just a to the 4th. You can also put 1a to the 4th. Plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. So that is what I would get if I were to take a plus b times a plus b times a plus b times a plus b. So we expanded that without multiplying it over and over and over again with the box. All right, we'll do a couple more and then we'll end there. Any questions about this? All right, let's do one. Let's see. What do I want to do next? Okay, let's do B. So first of all, for B, I'm in which row am I in? 5. So row 5 has a 1, 5, 10, 10, 5, 1. So let's write those numbers. I just like to write them so I remember. 1, 5, 10, 10, 5, 1. So my first number, my first term is X, and my second term is -3. All right, so let's just go through this really slow. So we got 1, and then I'm starting off with X to the 5th, -3 to the power of 0, plus 5. And now we got X to the 4th, -3 to the power of 1. You want to take your time and write this out. Does everyone see what I'm doing there? I'm just going down. I took my first term. I started that with the power of 5. And my second term, I'm starting with the power of 0. These exponents should always add to 5. So see how 5 plus 0 is 5, 4 plus 1 is 5. It should always add to 5. All right, plus, now I have a 10, and it's X to the 3rd, -3 squared. That's pretty long. And I don't know what exponent we're giving you on the test. I don't know if it's going to be a 6th row, a 7th row. I doubt it's that high. Plus, then what comes next? What number comes next? So we said 1, 5, 10. What's my next number? 10 again. And then I have X to the power of 2, -3 to the power of 3. Plus 5. Then it's X to the power of 1, -3 to the power of 4. Plus 1, X to the 0, and then negative 3 to the power of 5. So let me stop right there. So that's the hardest part of this, is writing it out. So let's look at it. Notice that I'm using my numbers. So I went 1, 5, 10, 10, 5, 1. When you look at your x's, I went x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Negative 3 started with a 0, then a 1, 2, 3, 4, 5. And when you're adding these powers, they should always add to 5. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. 0 plus 5 is 5. So anything to the power of 0, we can cross that out. So we can cross that out. We can cross this out. Now we're just going to simplify it out, and we're done. So I have 1x to the 5th plus, I'm going to come down a little bit, give myself a little bit of space. So I have 1x to the 5th plus. So now what you're going to have is you need to take and multiply your numbers. So you're going to take 5 times negative 3 to the power 1. Because we have two numbers. So what is 5 times negative 3 to the power of 1? 15 or negative 15? Okay. So my next term is going to be negative 15 x to the 4th. And now you're going to take and multiply 10 times negative 3 squared to get your next coefficient. That should be 90 x cubed. All right, try to figure out the next coefficient on your own. You don't have to. If you want, you plus a negative is the same thing as subtraction. So you could say plus negative 15, or you could say minus 15. All right, so take 10 times negative 3 to the power of 3. So I think, so negative 3 to the power of 3 is negative 27. Negative 27 times 10 is negative 270. And it should be x squared. So I only have one variable. All right, so now we're going to go down, and now you're taking 5 times negative 3 to the power of 4. Which is positive 405. Who got positive 405? I'm going to give you all a chance to type it in. Make sure that's what you got. So this is where I am now. So this term is here. And then this term was here. This term was here. Oh, wait, I think I'm off one. This term is here. This term is here. This term is here. All right, so what is 5 times negative 3? Who got 405? Positive 405. So plus 405 to the power of x. And then the last term doesn't have an x because you have x to the power of 0. And you just have negative 3 to the power of 5, which is negative 243. All right. We are going to practice this again. Again, I'm not sure if we're going to do our problem trail, but we are going to practice this more. All right, let's do one more that's not row 5 though, because that's a pretty lengthy one. I think if you go to question D, yeah, let's look at question D. Question D is just a row 3. So that should go a lot easier because that's just going to be 4 terms. What's the numbers in row 3? 1, 3, 3, 1. So this should go a lot easier. So 4x is my first term and negative 3y is my second term. So let's build it. We got 1. And then you start off with 4x to the power of 3. Now you don't necessarily need to write this negative 3y to the power of 0 because that is going to cancel out. But because I am teaching you, I am going to write it. On the test, feel free not to. And then we have plus. Then my next coefficient is a 3. And I have 4x to the power of what? 2. Negative 3y to the power of 1. Plus 3 again. 4x is going to be to the power of 1. Negative 3y is to the power of 2. And then our last term plus, I meant to write this in green. Hold on. That should be green. Okay. And then we have 4x to the power of 0. Negative 3y to the power of 3. All right. So now we just need to clean this up. Anything to the power of 0 can cancel. So I'm canceling that. And I'm canceling that. So let's go term by term. Let's start off with this term right here. Let me zoom on in. In your calculators, you're going to take 1 times, and then I have 4 to the power of 3. So, because I have to take this number and raise that to the power of 3. And then I have to multiply that by 1. So in your calculator, you're taking 1 times 4 to the power of 3, which I believe is 64. So your first term is 64x cubed. Bring down the addition sign. And you don't have to, Karma, if you want to. You could just wait to see if it's positive or negative. I always just bring down the plus sign. But the next term I know is going to be negative, so I'm going to put plus a negative, which is also the same as subtracting. So in your calculator, you're going to take the 3 times 4 squared times negative 3 to the power of 1. So you're going to type in your calculator 3 times 4 squared times negative 3 to the power of 1. Type that whole thing in your calculator just like that to get your coefficient. Which I get negative 144, which you could also say minus. So what's my exponent on x? See, I have x to the power of what? 2, and y to the power of what? So it's x squared y. Let's slide on down the road. Next one. Okay, so in your calculator, you're going to take 3 times 4 to the first times negative 3 to the second. Go ahead and type that in your calculator. You should get positive 108. And it's x to the first, y to the second. So look at what's happening here. X is to the power of 1. y is to the power of 2. And then for this last one, we don't have any x's. And in your calculator, you simply have 1. I mean, you could put 1 times 4 to the power of 0. But anything to the power of 0 is 1. So it's just 1 times negative 3 cubed, which is negative 27 y to the third. And when you're looking at your answers, notice how I started off with x to the third, x squared, x, no x. Y to the 0, 1, 2, 3. That would be your final answer. All right, so tomorrow I do have a problem trail. We may or may not do that. It kind of just depends.